here? Yes. Yeah. So I had not, yes. So we were not here because I had not pressed the button. I do this very often. Well, good thing there was this one time when I literally was live streaming for 2 hours and I realized I had not pressed the button to go live. And I was like, why are people not interacting? Where is the chat? Where are people? I felt so lonely. And then after, when I realized, I felt so dumb. But yeah, these things happen sometimes. Okay, welcome. Hello, everyone. How's everyone doing? Excuse me. Let me do the official thing. 3, 2, 1. Hello, how's everyone doing? If you are new to the channel, my name is Jose Luis. I run this thing called Parametric Camp. We do live streams roughly every Friday. Not been great at that lately, but I'm getting better. And what we do is we jump on a live stream in the company of beautiful people like Nicolas, whom I've seen very often here. He's a very fundamental part of the community, and Drilon, who I think I've seen before, but I'm not sure if we have engaged a lot. How are you doing? Good to see you, folks. And what I do is I jump on a live stream. I record tutorials live. It's a little bumpy sometimes. I go back and forth, etc., etc. And then after the fact, I take those videos, I edit them, and then I publish them in a slightly more refined way. Not great, not as polished as a lot of the YouTube content that you see these days, but good enough, I think. It just gets me going, you know? I have very little patience for video editing these days. Anyway, so if you're not new to the channel, welcome back and good to see you again. So what are we doing today? Today we're gonna have a bit of a shorter live stream because I'm a little late to what we usually. I was in a call with a wonderful professor whose work I actually admire, and I was lucky enough to be granted some time with him and had a beautiful conversation. Hey Nicolo, I can't believe this. How are you doing, sir? Good to see you. Greetings from Stuttgart. You still over there? It's a very big pleasure. Nicole and I are old friends from when he used to be here in Boston, and then when I used to visit in Stuttgart. Yeah, that night did not go well. Anyway, what was I saying? What was I saying? Yes, so what are we going to do today? Today we are going to wrap up finally, I can't believe I'm saying this, we're going to wrap up finally the very last video of the Advanced Development Grasshopper playlist or course or seminar or however you want to call this that we've been recording now for I think a full year now. I took a gap of streaming last year because I had a bunch of personal issues going on, but I'm back on track, so I'm happy to wrap it up. And what we're doing basically today is that what I typically do, if I may, where are we? Yes, so what I typically do, if I may, is that whenever I start a new playlist, I make this placeholder introductory video, which is kind of like, yeah, so this is what we're doing, but we're still work in progress, we're working on it, etc. So what I would like to do today is I would like to re-record this video. I just forgot something. I will need to, I want to re-record this video and I want to show snippets of, so I want to discuss the playlist. I want to show snippets of what people might expect from the playlist, and I'm going to remove the in progress here because it's not in progress anymore. We're done. And I would like to re-record this video now that we actually have the content. I would like to go over and explain like what are you going to learn, what is happening, etc., etc. So a bit more formally introduce the playlist forever and ever in the future. Because this video was basically saying we're recording things, blah, blah, blah. So I want to replace that. And that's going to be it. It's going to be done. Welcome. Thank you for coming and saying hi. So, and when are we hanging out? Are you coming to Acadia? Do I have to come to Icari? Like, when are we finding an academic excuse to hang out again? Okay? We need to make that happen, Nicolo. So, I want to do that. And then after I've done that, we don't have a lot of time, but I do want to make a short piece about bitwise operators in C# because I'm working on a small project with a collaborator actually here from the PCamp community, the parametric camp community, and we were discussing how using bitwise operators would be really helpful for an algorithm that we're writing. So I want to make a small piece to talk about bitwise operators, and I will probably use that video and place it at the very end of the C# learning C# playlist, which I think should be really interesting, I think. Before we go on, there is something I need to do, which I forgot to do before. It's gonna take me 30 seconds. Just give me 1 minute. Yeah. There you go. Not this one. Oh boy, that's not a good idea. So I actually have a PowerPoint that I'm going to be using to introduce the playlist. But I forgot that I wanted to add this tiny clip. Yeah, this is not gonna. So give me just 1 minute. I need to do something on here. I'm not gonna go anywhere. I would like, maybe we can just have a chat. How's everyone doing? I'm having coffee with you folks. Maybe we can do like a coffee session. Not a kitty for now, but moving to the US soon. Best Coast this time. Got sort of out of academia. Whoa, I think like we need to catch up, Nicolo. That's kind of breaking news in a way, you know? Okay. So I want to know what's going on with you. So what am I doing? Yes, this. Nope. Okay, and then I'm just going to add this. I'm basically clipping a video that I want to add that I forgot to add to the playlist. I'm just adding it right now. And I'm going to export. Why do I always do everything last minute? Does anyone feel like you're always doing things the very last minute? Oh boy, I'm so bad at this. And it doesn't get any better the older I get, for some reason. Nope. What happened here? Oh, not this video is not good. I didn't. Oh, I see what happened. Yes. Oh boy. Boy. Has anyone ever heard about bitwise operators and has been curious about what they are and how they work and why are they cool? You're welcome to say no, like it's never even considered, which is also perfectly legit because maybe you're missing out on something very cool. Who knows? We'll see. I guess we'll see today. And then here, and then here. I think we're good then. Okay, so all right, so then I should have this, and then I should have this. So I think what I want to do is I'm going to start the video, not here. I'm going to start the video here. I'm going to start the video here. Yes, I'm going to give blah, 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 and then blah, 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 and we're welcome, etc. And then the playlist is done, and I'm going to scroll here a little bit, and this is what we have. And we have a lot of stuff. But let me show you what we actually have. So we did this and that, and then the other thing here, and then I'm gonna poke my nose a little bit here, because then I move to the other side, and then I'm not gonna be able to poke my nose. And then geometry, and then references, and then we're gonna learn a little bit about stuff, and blah blah blah. So this is what it's gonna look like. And then I'm just gonna rewind, okay? And yes, and I have my cheat sheet. Where is it? The things that I want to say, which I'm going to forget otherwise if I don't have them written here on my side. Okay. All right. So are we ready for this? Nicholas, studied them a lot when I'm in college. When I'm working with Arduinos and stuff, I used them to generate a Hilbert curve where every point can be calculated in pi. I have no idea how I would do that with Bitwise Operators, Nicholas. I guess I need to invite you to make a video for the channel. That would be great. Okay, fractals and bitwise operators. Now you really got me intrigued. Anyway, let's do this. So, okay, I need to connect with myself. Because these videos, I really want to record them well because they tend to be very popular. It's the first video that people watch, and if they like it, they kind of stick to the playlist, otherwise not. You know, so you need to hype it up a little bit. Also, it's kind of interesting. I was watching through the videos and I noticed how my hair and my beard actually mutate very strongly over videos. It's kind of a catalog of Jose Luis's grooming state in a sense. Anyway, so let's do this. Okay. All right. In the previous video, I said, welcome to our new series on advanced. I don't want to say new series. Um, uh, um, okay. Okay. I'm just going to start and try and try. And if it doesn't work out, we'll do it again. You know how this works. You've been here. So let's just try. It shouldn't take too long. It should take like 10 minutes, hopefully. And then we can get to Bitwise Operators. Okay. Hello, this is Jose Luis here at Parametric Camp, and welcome to this new series called Advanced Development in Grasshopper. What I would like to do is, in this series, I would like to teach you advanced techniques on how to, okay, what am I teaching here? Advanced techniques, advanced techniques, if you're, or maybe I can phrase it as saying, if you're here, it's probably because you already have an understanding of regular Grasshopper, but you're curious about programming inside of it, etc., etc. Or you have hit limitations that relate to data and to life. Maybe that's what I want to say. Or maybe I want to say that after I have explained what this is about. Okay, I'm just going to try. Let's give it a try. Hello, this is Jose Luis here at Parametric Camp, and welcome to our new playlist, Advanced Development in Grasshopper. In this playlist, what I would like to teach you is all the extra good stuff that is beyond using Grasshopper in the standard vanilla way, by which I mean dropping standard components or maybe plugin components and created parametric modeling using connecting the wires and blah, and blah, 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 blah. No, wasn't liking that. So what is it that we're teaching here, actually? Is it about scripting? Is it about, hey, Wasif, what's up? Is it about, or maybe I should start by making the case of like, if you're here, it's probably because, well, if people are here, it's probably because YouTube recommended the video to them, maybe. I don't know. Hey, Victor. Yeah, I have a bunch of lights, and also I have this light here. Yeah, it's kind of a lot. I don't know what's going on. I have a light here, I have a light here, and I have a light here. And you see, if I do this, the color changes. Anyway. No, Wasif, you didn't miss it. You are in the session today. We just started. Okay, so what are we gonna say here? What are we going to say? What is this playlist about? This is about learning advanced concepts. But what are advanced concepts? Advanced concepts are pretty much anything that is not vanilla Grasshopper. By vanilla Grasshopper, I mean doing parametric modeling by using the standard set of components, joining them by wires, and creating definitions like that. What I would like to teach you is how to dig a little deeper in all the other spectrum of possibilities that Grasshopper has that is opened up when, instead of using the standard tools, you engage in scripting and you engage in the development of plugins or customizing. Maybe customizing is a good word here. If you are here, it's because you're probably... So what I would like to teach you is, in particular, how to use the C# script component. We'll walk you through all the way from scripting your own components inside of it to advanced manipulations, messing with the interface, all the way up, doing real-time simulations, all the way up to developing your own plugins. Maybe that is the way to phrase this. Let's give this another try, okay? Yeah. Okay. Hello, this is Jose Luis here at Parametric Camp, and welcome to a new playlist called Advanced Development in Grasshopper. What I would like to teach you in this course is how to go beyond what could be referred to as the standard use of Grasshopper, where we can create parametric models by using the standard set of components in vanilla Grasshopper, or maybe even plugins that you have downloaded from third parties, and creating your definitions by placing collections of these items, joining them by wires, and therefore developing a workflow. That is a very good introduction to parametric modeling. It's what Grasshopper is designed to be really good at. But if you are here, it's probably because you have detected or you have seen that there is all this other deeper layer to Grasshopper that can be opened up if, instead of using the standard set of tools and components, you engage into more deeper customization of your workflows, starting with using, for example, programming inside of Grasshopper via the C# script component, or perhaps the Python script component, all the way to doing things with these techniques that are very difficult to do with standard Grasshopper. For example, iterations, for loops, repetition, or even real-time simulation dynamic form finding. All the way leading up to perhaps even getting so good at this that you can develop your own plugins for Grasshopper that you can use for yourself, you can use in your company, or share with the rest of the world and contribute back to the community. So in this playlist, in this course, what I would like to teach you is how to supersede that standard use of Grasshopper and engage into deeper customization by using scripting inside of Grasshopper and by developing your own plugins. And in this course, we will actually together develop one plugin, native plugin, that we will actually publish by the end into Food for Rhino and Yak. So what is this going to look like? Well, the playlist, I just finished recording it like last week. So I'm recording this video post, the whole thing. And you can see that the playlist is actually quite comprehensive. I touch into many topics that are pretty cool. All the videos are designed to be building on top of each other incrementally. So I mix them, I mix concepts with exercises. So hands-on, let's practice what I just showed in the previous exercise, in the previous lecture. And I actually really strongly recommend that you follow them sequentially after the other, and that whenever you hit an exercise, you actually take the time to practice with me and building whatever we are building in that particular exercise. In particular, what I would like to show you is, first of all, I would like to introduce you to many topics in this playlist. The first one is going to be talking about Rhino Common and talking about the scripting engine that lives under Grasshopper and under Rhino that we can use to access all the good geometrical information and geometry processes. I would like to then use the C# script component as the baseline where we will practice and prototype all of our homebrew algorithms, if you will. So I will basically try to teach you how to do what you already know how to do with standard Grasshopper components, but implement the same functionality in one C# component. There are many advantages to doing this: performance, access to for loops, access to iteration, dynamic simulation, things that I will explain over the course of this playlist. Similarly, because we will have access now to scripting, we will also have access to many more advanced geometry operations that sometimes are either hidden or not available as part of the standard set of components. We will use that, for example, to do advanced operations with intersections, with nerves, with meshes. We will learn how to load external libraries and third-party DLLs in our Grasshopper C# script components. And I will point you to references of where can you learn more about how actually vanilla or standard components are written, and where can you see versions of the code that is running in the components that you already use in standard Grasshopper, so that it helps you do the transition from something that you already know, which is the Grasshopper component, to how that very same functionality would be written in C# script. That will be a really useful exercise to understand the translation and moving from the higher level, the Grasshopper component, to the lower level, which is writing the same algorithm on your own. I will also use some of this time to review some programming concepts that are important and fundamental, and that will help us a lot understand how to improve our algorithms and why certain things work the way they work. For example, differences between structs and classes, or for example, how to actually work with data trees, but not using standard Grasshopper tools, but using data trees inside of scripting environments, which is slightly different than how it's done in vanilla terms. I would also like to talk about how C# script components are basically classes, and how by understanding where certain properties live and what the relation with the Grasshopper execution cycle is, then that will allow us to do, for example, dynamic simulations or computations that are running periodically and that allow us to generate, for example, dynamic form. I will use the example of a pendulum. I will use the example of a elastic rope, and I will use the example of a bouncing ball inside of a rectangle to illustrate this. These will be really fun exercises and very easy to do. I would also like to teach you a little bit more like hacky stuff. So for example, how to use scripting to manipulate the UI of Rhino and the UI of Grasshopper themselves so that you can do things such as, for example, more beautiful visualization of your algorithms by screen grabbing something that has a pure white background and therefore composing that into a video that you could use for your own YouTube tutorials or who knows what, or for presentations. And even more advanced topics, contributions from the community, like the plugin Remo Sharp from our parametric cam contributor Aras2, who made this very awesome framework to allow people to work remotely from different places in the world with the same Grasshopper definition. We recorded this video with me being in Boston and him being in Tokyo, which was actually quite fun. And then all of this will help us at some point move on and evolve to superseding scripting inside Grasshopper. And I will teach you how to use Visual Studio to create your own native plugins that you can compile, that you can share, and that you can add icons to. I didn't do this in this example, but that you can package and share with the entire world, just like any other third-party plugins that you may have used before in Grasshopper. I will use that as well as a way to discuss certain things that are interesting for development. So I will teach you, for example, the difference between the different Grasshopper formats that are available. And I will teach you things such as how to make your development a bit more lean, a bit more efficient by, for example, connecting Visual Studio with some files in Rhino and using breakpoints and all those things that are more technical and more related to development. And last but not least, what I would like to teach you is once you have built a very awesome plugin, how can you share this in Food for Rhino so that other people can download it? Or how can you use this how can you publish it in the package manager so that people can open the package manager in Rhino and automatically download and install plugins themselves. We will wrap up the playlist with this wonderful conversation that I had with many people that I actually admire and whose work has been pivotal and fundamental to the Grasshopper community, people who have developed plugins that are extremely popular and that have enabled many people like myself and other people to do really great things with Grasshopper. They are really good examples of this idea of having a concept for a tool, developing that tool and making it available publicly to the community. All right, I was speaking a lot. I needed a break. But yes, so now what I want to do is I want to go over some of the assumptions and wrap up the video. So sorry, I just needed a minute. Okay. So how is this going to work? Well, you've seen the playlist. It's just a bunch of lectures combined with exercises. I very strongly recommend that you follow them one after the other and that you try to get hands-on. We will be, over the course of the full playlist, building up, we will be prototyping a plugin and we will actually then transition to building that plugin natively, which is a really good exercise if you ever want to do that by yourself. I will, however, build on top of two assumptions. First of all, if you're here on this playlist, you're probably already familiar with standard Grasshopper. So you know how to use Grasshopper, you know how to build definitions, you know how to do parametric modeling. So, because I will not be reviewing those concepts in this playlist. If you're not yet familiar with Grasshopper, then I very strongly recommend that you go and you check out our Introduction to Parametric Modeling playlist. In that playlist, I go over from absolute scratch, no assumptions, beginner, zero. I go over how to use Grasshopper to create parametric modeling. A card should be popping up somewhere in the corner if you haven't seen that, and there will be a link to that playlist in the description of this video. So I'm assuming you know standard Grasshopper, but also for this playlist, I will be assuming that you are familiar with C# programming, with the C# programming language. So In this video, we will use a lot of C# programming, and I'm also not going to cover C# scripting inside of this video, because for that, I also have a playlist called Learning C#, which covers C# as a programming language standalone and with no relation to anything, just console applications and the program itself. If you are not familiar with that, there should be a playlist popping up as a card as well somewhere in the corner, and there will be a link in the description of this video as well. And with these two things, if you know standard Grasshopper and if you know standard C#, what I would look like to do in this playlist is connect the dots and help you understand how to use a programming language that you learned as a standalone thing and a parametric modeling environment, which you also learned as a standalone, combine and harness the power of that combination. This is what this playlist is mostly about. I'm going to be focusing on the technical aspects of scripting inside of Grasshopper, building geometry using C# scripting, and developing geometric operations using code as a medium. So we're going to be using very, very few standard vanilla Grasshopper components. And also, if you're interested in what we're doing here, a really good extension to this playlist is checking out some of our algorithmic modeling challenges where we build things using standard Grasshopper and then we rebuild the same thing using C# scripting inside of Grasshopper. It's also very helpful to understand the transition between Grasshopper and doing the same thing using code. There should also be a card popping up to a playlist with a bunch of those algorithmic modeling challenges. We will be building a plugin together, so I will actually not finish the entire thing. I will only do half of it. So it will be an interesting exercise for you once you finish the playlist to, if you want, continue building the entire thing just as a practice. And last word of warning, I finished recording this playlist at the beginning of 2023. So if you're watching this from the far, far future, maybe Grasshopper has changed, maybe Visual Studio has changed, maybe Rhino has changed, or maybe the world has ended. I don't know. But depending on how far away in the future you're watching this, the content might be outdated. I will try to do my best to add videos at the very end of the playlist with updates when technology changes or removing things that might be obsolete. But just take these things with a pinch of salt. I am teaching this using Rhino 7 and using Grasshopper 1. As of right now, Grasshopper 2 is in alpha. It's still not available for public release. It's also not available for scripting. So whenever that is the case, I may re-record some videos and update the content for Grasshopper 2. But in the meantime, we're still not there yet. And that was a lot of talking just to introduce the playlist. I'm hopeful that you are excited about what we're doing. This will be really good if you really want to improve your skills as a computational designer and bring them to the next level, because this list will help you not anymore build things for your own self, but it will help you build things that you can then share with the greater community, which is perhaps like the next step to becoming more of a senior computational designer, if you will. I don't know. At any rate, thank you anyway for considering this playlist. I hope you enjoyed. I hope you learned a lot. And as usual, if you want to learn more, feel free to follow us on social media. Feel free to join Discord. Feel free to drop us a message anywhere if you make something cool with what you learned in this playlist. And maybe subscribe to the channel, turn on notifications, say hi in the comments, whatever your form of expressing gratitude might be. Thank you very much. And let's talking and mod starting and more starting. I'll see you on the next video and let's see what this feels like. Let's write some awesome Grasshopper plugins. See you in the next video. Bye. All right. Can Python be used in the same way as C#? Yes and no. So Python can be used in a very similar, let me go back to, yes, and I want to shut things down here. So Python can be used in the same way as C# when you're doing scripting inside of Grasshopper. So that means using the Python, the Grasshopper Python component, to create algorithms. What you cannot do with Python, as far as I understand, is to develop your own native plugins. What that means is that with Python, you cannot basically go to Visual Studio, write a Grasshopper plugin, and then compile it so that it shows up as Grasshopper components that people can download and use. That's not a possibility because Python doesn't compile. And I don't know of a way of wrapping up compiled C# components that actually run native Python code, as far as I know. So yeah. Can we use in Archicad? Archicad, can we use what you're learning in this playlist in Archicad? I'm not sure because Archicad I'm not very familiar with. It's funny that you ask, Hosam, because I literally had a conversation about Archicad and how popular and relevant it is in Europe, for example. But I'm not familiar with the scripting environment inside of Archicad, so I can't really help you. I'm not really sure. Okay. All right, so I'm going to take a 1-minute bio break, and then I'm going to come back and we're going to record a short piece on Bitwise Operators. And for that, I'm actually going to need my notepad, so I may need to set up my laptop. What am I going to set my laptop? I may need to set up my laptop to do the sketching, drawing, etc. Do I have my pen? Yes. Oh, it's got dust on it. That's how long I haven't used it. All right, I'll be right back. Give me 1 minute and I'll be right back. And then we record some C# Bitwise stuff. Okay, I'll be right back. All right, give me a second. I need to install the laptop. All right, so my laptop and I need to plug this in somewhere. Where can I plug this in? Oh boy. Here. Is this too far away? No, I think we're good. Would you advise anyone to learn both Python and C# or just focus on one? Yemi, I would definitely recommend that on the long run, you learn both because they're actually fairly different and in a very interesting way. But I would also definitely advise that in the short run, if it's your first programming language, you definitely focus on just one. You understand and you practice all the computer programming paradigms in one platform. You get better at doing basic algorithmic code in one platform with one language so that you develop like a general understanding of computer programming. And once you are familiar with computer programming in general, then it's much easier to switch to other programming languages where the only thing that you have to learn is the syntax, but you are already familiar with how code is written as a general technique. Okay? That would definitely be my advice. But this is a really nice low level channel. The whole channel is awesome. I guess you can't post links here on YouTube, right? Nicholas, would you like to post that link on the live channel on Discord? Because I don't think you can post anything on YouTube, on the YouTube window. Okay. Okay. I forget. No, sorry. How did I do? How did I do? How did I connect to? Oh, okay. Oh, how did I do this? I need to get on the same wireless? Is that what we're doing? Okay. So I guess, where are we? I'm trying to connect my computer to my other computer. Not being very successful. I wonder if I'm going to break the... I hope I don't break something. Hello, hello. Are we still there? Did I glitch something? Oh boy. And connect to a wireless display. There you go. I got it. And it looks like I didn't break anything. Is that correct? Well, let's cross fingers. Yes. And this is the pen. And I see... Ah, but is this Sebastian Lag? I like his videos a lot.
Hi everyone. I spend a lot of time.
All right, I think we can link to this video. It looks pretty neat, pretty neat. Yeah, it does look very neat. Oh, sorry, I'm not even... Yeah, it does look pretty neat. Okay, let's link to this video. It's going to be awesome. Yeah. Okay. So, do I have access to Sketchbook? Yeah, but I don't want that here. I want this here, yes. And here. No. Okay. Yeah, my laptop is not properly connected to, because so I should be here, but this is not really. Okay, I need to disconnect then. Yeah, okay. Okay, I'm going to disconnect. Oops. Oh, did I break something? Okay, and now I'm going to try to connect again. And okay. Yes. I am connected. And then it's still not taking my input. Input from this device. Yes, I want input. Oh, wait. So why is this? Wait, so it is the pen that is not working actually. So it looks like the pen is not working. Do I have to put batteries on this thing? Is this what's going on? Let me change the battery of the pen. See if that was the problem. Do I have batteries? That's a very good question. Looks like I have some batteries here. Well, if you're new to the channel, as you can see, this channel is very informal, homebrew. Is this... Oh, what? What? Oh, wait, it's a 4AA. This is a tiny battery. Oh, wait. Oh, damn. I think it's a battery that doesn't... Oh, it's a 4... I didn't even know this existed. So it's a 4AA. It's an AAA battery. Crazy. Huh. Oh, okay. Which I don't have. So now I can't do... why do things don't work? Why things don't work the way it should work? It's going to be very difficult to explain bitwise operators without sketches. Yeah. I wonder, can I make sketches just like with my finger? Because can I get away with just doing finger sketches like this? I wonder if I can do that. I mean, I'm gonna have to because I don't have an option. So do you want to... No. Okay, I can also just draw with my mouse, I guess. Which is awful, but but I can say, okay, 0, 0, 0, 1, 0. I may actually have a better handwriting with my finger than with my... That could totally be the case. Okay, so I guess we're gonna have to do that. Sue, oh, I saw your comments recently. Thank you for your kind words. Should I study math in computer science field to be more advanced in plugin development? I don't think studying math per se will make you a better plugin developer. I don't also know about computer. I don't know. I never studied formally in either math or computer science. I've taken some classes on both. But at the end of the day, it's the thinking that I think it's important. I mean, it definitely won't hurt. So if you study math and computer science, it will definitely help you. But I think a lot of it is just practice as well. So if you want to make something, just give it a try and try to do something and see. Yeah, I actually don't know about that. Anyway, okay. Okay, so where are we? We're going to do bitwise operators. So I'm going to go to the repo where we had all the stuff. Learning C#, and out parameters, enums to the arrays, out parameters, and maybe we get something here. Why am I still using Visual Studio 2019? How did this happen? And why can I not? All right, so let's plan this. First, I'm going to create a new project, and the project is going to go here under 64, I guess. Bitwise Operators. It's going to go there, and it's going to be a console app for the .NET framework. It's going to be, and let me find, where is this? Pcamp on GitHub, learning C#. Okay. Here, and it's going to be called Bitwise Operators. operators. Create new solution. Yeah. Okay. And I'm still using 2019. I just wanna here 2022. Let's update. It's about time. Okay. Yes. So Bitwise Operators here. It's opening in the other window. What CS course did I take? I've taken a bunch. I took CS50, which is a very popular now online program. And I've taken algorithms class, I've taken machine learning courses, I've taken a bunch of stuff. Okay. And there's a huge typo here. All right. And okay, but let's think first. So what do I want to do? I want to, as a script, what do I want to do? I want to introduce what bitwise operators are conceptually. Perhaps draw similarities with Boolean operators. And why are they useful? Should I explain this? Why are they useful? Very fast numerical operations. Interesting data manipulations. Then, hey Chandra, how are you doing? Good to see you. Then, and operator. Explain. First, show numerical examples. Where are these results coming from? And then explain whiteboard. And then I want to do the OR operator. What is the OR? And also we're going to do some whiteboard here. And then whiteboard plus exam code. And then also whiteboard plus code. And then byte shift. Bit shift. Also whiteboard plus code. And once we do that, I would also like to record another video, which is going to be examples. And for examples, we're going to do, for example, what are we going to do? I'm going to do a mask of flags, and then we're going to do RGBA extraction from color. What else could we do? I guess that could probably be it. Okay, so I'm gonna move all of this out of here. And then I'm gonna move it all the way here to my other screen. And then console, read key, and then here we're gonna make an example. What could be an example? An example could be integer, for example, bit and that's going to be, for example, the number 128 and 128. And this should be console log for example, bit end. And if I run this, I should probably get 128. Is that correct? Yes, I'm getting 128. And I'm gonna let the system position this. But that's a terrible example, bit or, and that's going to be 128, 128, console write, bit or, and that's going to be 64, and that's going to be 0. No, that's going to be 192. Well, maybe we could do the same thing with 64, and this should be 0, correct? 0 and 192. And if I do 192, I get 192, right? Yeah. What could be a good example so that it's... And then if I say bit shift, and I say, for example, the value of 1, I'm going to shift it 8 times, and that should be... what should that be? 256? Okay. I don't like these numbers. Well, actually, I do kind of like these numbers. I'm going to shift this 7 times so that it becomes 128. Yes. Okay, so let me write this example a little better. Okay, and then here I'm going to do this, and then this is going to be here. It's going to be okay. Check the last bit in a number to check if it's probably more efficient than a module of 2. You're absolutely right. Yes, you are right. Okay. And then we're gonna make this. Can I make this bigger? The color, the font. Can we make this 36? And then can we just make this window smaller? The width, the height, the width. Can we make it 80, and can we make it 16? Okay. Yes. Okay. Mr. Vector, you're great. Thank you, Sajin. Okay. All right. So we would record an introduction. No, actually, maybe this can be the introduction. Can this be the introduction? Let's do this introduction. So I'm going to introduce like, hey, this is a new video, and I'm going to explain Bitwise Operators, and which looks something like this. So for example, Bitwise is 0, Bitwise is 192, it's kind of the addition, and 1 is 128. And I would like to say, well, this is kind of similar to Boolean operations, but what we're doing is we're going to do them individually with each one of the bits of a number, and I will explain 2 examples of why this is interesting, and we'll do a video out of that. Okay, so that's going to be it. And what am I going to say? Is this part of learning C sharp? Is it not? What are we doing here? Playlist. What do we have right now in learning C sharp? Enumerators. I should numerically multidimensional arrays, out parameters. What did I say here? Hi, my name is Jose Luis, and in this video I would like to teach you how to write functions in C sharp that can... Okay, yeah, I don't know what I'm gonna say, so I'm just gonna run with it. Okay, let's just do it. All right. Hello, this is Jose Luis here at Parametric Camp, and welcome to another video where I would like to teach you a little bit of C sharp goodness. In this video, what I would like to cover is bitwise operators. And if you have never worked with bitwise operators, they're actually quite interesting. I would like you to think of them as Boolean operators. So you have and you have or. And we will also learn some other operators like bit shifting. It's just that the idea that I would like you to get out of this video is that what we would like to... Starting over. And it's going to be 0. It's going to be 192. And this is going to be 128. Is it clear if I do it like this than if I do like... I don't know. All right, let's start over again. Hello, this is Jose Luis here at Parametric Camp, and welcome to another C Sharp video where I would like to introduce you to bitwise operators. If you have never done bitwise operators, I would like to show you what they look like. So there is this thing called the AND bitwise operator. There's this thing called the OR bitwise operators. There's more, there's SHOR, NOR, etc., etc. And there is this special operation called the bit shift register. What these operations do is that they are very similar to Boolean operations like AND or OR. The only difference is that instead of operating with Boolean values, with true or falses, they operate with numbers. And what they do is that they do the AND, the OR, the XOR, or whatever operation, they do it individually with each one of the bits that form that number, each one of the zeros and ones that make that number. And therefore, we can create very fast, very interesting numerical operations that are extremely performative. They're even more performative than regular arithmetic. And they do have some interesting applications that we will see in the video after this one, in which I will make a couple practical exercises on what can we use bitwise operators for. So I'm going to first explain why 128 and bitwise 64 is 0, why 128 or bitwise 64 is 192, which kind of sounds like the sum of both, and why displacing the digit of 1 7 units to the left ends up becoming 128. I'm going to explain that using the whiteboard. I'm going to show you some examples, and then I will record another video after this one where I will make two practical examples of why this can be interesting. Okay, so now let me go to the whiteboard and let me Actually, maybe we can use text here. Can I do text here? Okay. Ah, you know, oh, you can't see that. Ah, weird. Okay. Okay. Can I edit this text here? What? No. Edit text layer. Okay. Can you see the text? It's super tiny, huh? We need bigger than that. Oh boy. Nope. I want to move this. How can I move it? This one. Okay, and then maybe what I can do is I can change the layer here, edit the text layer, and then I can do, and then do oh, but that, I want that to be another layer. So I'm trying to make this diagram in my very makeshift kind of low level. Okay, so I'm gonna do that. Then there's gonna be another layer, which is going to be just a straight line. And what is a straight line? Oh boy, I feel like an old person. Why is this not drawing a line? Okay. Can I just do a line here? Yeah. Oh, let's do black. I want to do black. Okay. So, so that's it. And then I would like to place the character and here. And then after that, I would like to now do 0, 1, 1, 0, which in decimal is that's not a good example. This is a terrible example actually because it's not showing any numbers that get turned on. Yeah, I want to rewrite this. Nope, not a good example. So what can be a good example? It can be, for example, thing. So this can be 192. So I want to create an example with a few numbers where there are several situations of things that get turned on or off. And then this can be, okay, so let me open the calculator. And I'm going to show you because this is very nice. So you can do, for example, you can do programmer, you can turn this to binary and you can say, I want something that is 0, 1, 1, 1, and then 0, 0, 0. And that is going to be 112. Correct? Yeah, that can be 112. Yeah, because actually that 128 that I have on the screen is not good. Okay, so 112 will be Actually, you know what? Now let me redo this. I want 0, 1, 1, 0, 0. No. I want 0, 1. Oh, what? That I want decimal. What is this? What? Now I'm writing in binary here, exactly. Binary is going to be 0, 1, 1. Ah, it's not the best morning. It's going to be 96. Okay, so that's what I want. I want 96. Can I do smaller numbers, perhaps? Maybe I can just do 0, 1, 1, 0, which is the value of 14. Ah, why do I not know what I want? You can't see my calculator. Oh, I'm sorry about that. Sorry, I was doing things on the calculator here, so I was doing the programmer thing where I was just writing in binary numbers for combinations. No, so I'm in binary. I want 0, 1, I want 1, 0. So maybe this number, I want 96. Okay, so I'm going to do 96 here on the screen. Actually, wait. In decimal, what is 64? Is 0, 1. And what is 32? Okay. So what? Okay. Maybe I can do 2 examples, and that will be a little easier. And that's 64. Yes. And now this layer here and this layer here is going to be 192, which is this one and this one. So that can be one way we can do AND with 2 very simple numbers. And then, for example, I can copy and I need to find something a bit more, something that allows me to do a bit more fluent. And that's going to be 110. And then another one can be and that's going to be here. No, it's going to be this, and then this, and that's going to be 53. And that's going to be go here. So this one is going to be a little more complicated. And then I'm also going to draw a line. So where are we? I'm going to draw a line here. Okay, we're going to draw a line. We're going to, can we duplicate layers? Yeah. Can we duplicate the layer there, and then can we just move the layer? The one above should be the OR operation. Yes, it's wrong. You're right. Ah, I'm not having it today, huh? Oh boy. I think I had a rough morning actually. Oh, and my battery for the microphone is kind of dying. Yeah, this is not working. This is actually OR. You're right, Nicholas. Oh, where is everyone? Where did you guys go? Okay. You know what? I clearly need a bit more preparation for this. I thought I was just gonna be, well, let's just, okay, never mind. Hey, never mind. We can do this. Yes, it's gonna take a little. So, okay, so that's going to be this one, and then this one will be, okay, for this one, where are we? Here, I'm going to duplicate this layer. I guess I'm just worried because I'm kind of rusted. How can I move things around? Why can I not move anything around? Oh, I'm so frustrated right now with this software. What is going on here? Oh, now. Wait, okay. Seriously. I need to find a better way. This is just, I don't like this. And also, I still don't have it right. Oof. Should I just switch to Illustrator? Is that what I need to do? Or Photoshop like Freya does? You know? Oh boy. I'm really not having it today. And then here, we're going to do 1, 0, and then this is going to be 1, which I don't even want to try to do because I'm totally gonna not, because it's clearly not my binary day. 36. So this should be 36. Okay. And then I will hopefully do similar examples. I will hopefully do similar examples on this side of the screen. On this side of the screen here. No, why are you? Oh, I hate this software. Why is this so clunky? There you go. Oh God, that took forever. And let me just make sure that the numbers are correct. 10 and 53, because I don't want to have to redo the thing. 36. Okay, we're good. Okay. Okay, so let's go here. Then I'm going to turn things off. Okay, let's do this. Let's go. Beautiful. Let's get started. So the first thing that I would like to explain is the AND bitwise operator. And as I said, what's important about bitwise operators is to understand that the way they work is that they perform Boolean operations, but they do it at the level of every single bit, every single 0 and 1 that is part of a large number. So for example, in the example before where we said we want to do the AND operation of 122, 128 and 64 at a bitwise level. So what we need to do is we need to understand that 128 in binary is written as 1 and then 7 zeros. And then the value of 64 is written as 0, then 1 in the 7th position. And then the rest of the is trailing zeros. So if you imagine doing operations, Boolean operations between each one of the bits, one by one, of the numbers that form the digits of 128 and 64 in binary, you could see that if we did the AND operation, 0 and 0, false and false, is false. 0 and 0 is false. 0, 0, 0, all of these are false. Then false and true is still false. And true and false is also false. What that means is that the result of doing the AND bitwise operation between two numbers where there is no value, there's no bit, where both bits are true, is something that is completely zero. And that's why the bitwise operation 128 and 64 is the value of zero. However, if we go to a more elaborate example, so for example, the value of 110 in decimal is all these digits that you can see here in binary, and the value of 53 is all these digits that you can see here in binary as well. If we do AND bitwise, same thing applies. The only thing we have to do is one by one, we have to perform AND at each bit of the digits. What that means is that false and false is false, false and true and false is false, but then here, true and true is actually equal to true. Let me turn the result on. True and true is true, so then here we have a 1. This is false, this is false, this is true, false and false, which ends up giving us the value of 36. So if we actually go back to the code and I were to do now, for example, bit and is going to be equal to 110 and bitwise 53. And if we were to print this to the console again and say, what is the value of this? Let's see if we get the result that we were expecting. So I'm going to run this, and the result is the value of 36, as we could see in our bitwise AND operation. All right. So again, bitwise AND basically means taking two numbers, looking at their binary representation, and then performing the AND operation with each one of the bits, each one of the zeros and ones, correlatively, one at a time. Okay, and then what I would like to do now is I would like to do the same example, but with AND. So what I'm going to do is I'm going to start copying and pasting. I'm going to start copying and pasting. No. All right, I'm going to duplicate this and move it here. Oh boy, here we go. Here, worked out well in the end. I think so too, thank you. Nicholas, have you ever thought of doing some live streaming, some videos yourself? I think with all the fabrication experience you have, you could very much contribute something to the world, you know? Then here I'm going to, this is so slow. Or maybe I should just like learn the shortcuts or whatever. Brief transform. And then it's going to be the vertical pipe here. And this is going to go here. This is going to go here. Turn this off, turn this off. Then this pipe is going to go here. Turn it off. Oh boy, I'm really clunky with this software, definitely. And then I'm going to copy the other one. Well, I have to copy the answer actually. So that's going to be this. I'm going to move it all the way up. I'm going to, oh, I hate this. And then I'm going to now edit it, which is 192. So that should go there. The user guide to Kuka PRC. I have 100 pages done, but I need to go over it again and finish up some example. Oh, you're writing the Kuka PRC guide? Nice. Is that, are you working with Johannes and Sigrid? Is that what's going on? And then here, I'm going to duplicate this. Then I'm going to transform. And then that's going to go here somewhere. And here. Oh my God, I'm so slow at this. Long overdue on your side. I mean, don't we all have so many things going on? You know, it's kind of hard to keep track. I'm hating my life so much right now. That's an exaggeration, obviously. I don't hate my life, but I hate not being fluent with tools, and this one is very much killing me right now. I think it's doable for freehand drawing, but I'm really not getting it for this kind of more vector kind of situation. I just can't copy and paste. Ah, oh God. Okay. And this icon that just flicks around. Okay, and then I'm going to do this by hand. The result of this should be, what is it gonna be? 0, 1, 1, 1, then 1, 1, 1, 1. So that should be what, 127? No. Is that what it is? Am I gonna risk it? Let's just, do I have the calculator on? Yes, so in bitwise, 7 ones is 127. Okay. All right, well, that ended up being a nice number actually. Okay, so then I'm going to, in the code, I'm going to write here bit or equals this thing here, but with an or, and where are we here? Not that one. And then here I'm gonna do bit or, and debug 127, yes, and okay. All right, so now let me turn things off. Oh, okay. All right, can you please, folks, yell at me if the battery, if I run out of battery? I think I'm not great. Actually, that's not true. Yeah, it is true. Okay. Okay, so let's do this. Now, similarly, if you know Boolean operations, you know and you probably are familiar with the OR operation, right? The OR, the bitwise OR operation, is written with one vertical pipe as opposed to two, and it's very similar to what we've said before. The idea is that if we have two integers, two numbers, and we want to do bitwise OR, the operation that we do is that we look at each one of the bits and we perform an OR operation on each one of them. We do that with the single vertical pipe, and the result, for example, of doing this would be false or false is false, false or error, all of these are false, but then false or true is actually a true value, and true or false is also a true value, which means that 128 bitwise OR 64 is 192, which in this case is almost like doing an addition. This is not a general case for bitwise OR, but it does work the same. Can you see the difference between the bitwise and the bitwise OR for the same two values? And let's look at the other example. The other example is actually quite fun because if we start adding each one of the each one of the bits and you start performing the OR operation with each one of them, you can see that this one, false or true is true, true or false is true, true and true is true, sorry, true or true is true. Long story short, basically the only scenario where we get a zero is if both numbers, both bits are zero, which ends up giving me the result of 127 from a bitwise OR operation. If we go back to the code and we see that we do bitwise OR for 128 and 64 and bitwise OR for these two numbers, what we will get is the exact same result that we just saw. 128 or 64 is combining the two and is 192, and this is going to be 127. So basically everything is a 1 except for the very first 0. All right, beautiful. So that's great. And I think the last thing I would like to talk about is the bitwise shift operator. All right, save. Can I save? So how am I going to make a diagram for that? The bit shift operator is basically moving a number, moving a digit, like a block of digits back and forth. So what I could do is what I could do is I could say, what can we do? We can say, let's say that we have the number 1, which is decimal 1, okay? And then with decimal 1, why do you get? And for decimal 1, we offset it by 7 positions. And so can I do here, but it just overlaps because of course here, and maybe I just take this off. It doesn't look great, right? This is what happens when you want to take shortcuts. Actually, this one doesn't look too bad. And perhaps I want to remove this one. Yes. So then what's going to be? Then this one is going to be, now that I have then, oh, sorry, I have to actually do this, which is going to be 128. And that's going to be a value of 1 over here. Why do you do that? Okay, it's fine. It's fine. Patience, patience. So we have that, and then we go here and we say, you know what? If I have, and I do bit shift to the left, the right. If I have this, and then I do bit shift to the right. Hey Jay, hey Blueprint Studio, what's up? And I do bit shift, I don't know, for example, 1, 2, 3, 4 to the right. Then what I will get is I will get 0, 0, 0, 0, and then which in decimal is, what is it? 16? No, 15? No. 1, 2, 4, 8. It's 8. I hope I'm not getting this wrong. Okay, and then I'm going to remove this line here, which is not great. Okay, is this looking terrible? It is, right? Ah, folks. And then here. So if I do an example that is a bit more complicated, so something like 0, 0, 0, 0, and then 0, 1, 0, 1, which in decimal is so 0, 1, 2, 4, and 5. So this is 5. And then I do a bit shift 3 positions. For example, I'm just going to do this here. I'm going to move this to the other, or not. I'm just going to move this here. If I do that, then the result should be, the result should be what? It should be, yes, which in decimal is what? 1, 2, 4, 8, 16, 32, and 4, 36, which in decimal should be 36. I need to double check all of this because if I record it and then it turns out that I messed something up, I'm just going to be really bad humored. I'm just going to be really cranky today. Okay. Here, then here, then here. Is this looking good? Is it looking terrible? It's not looking great, but okay. Oh boy. And then if I take that 0, 0, 1, 0, 1, let's hope it's 36. If I take that and I change, I do 1 back to the right, and then I change this to 0, 0, 0, 1, and then 0, 1, 0, 1, which in decimal is 64. That's not 36. Wait, is it 36? 8. So 8, 16, 32. Okay. Fine, 36. So that would be 16. 16. No, I've totally got it wrong. Can someone check this for me? The binary numbers. Ah. So that would be 8, 16, and then that would be 1, 2, 4. This would be 20. But the 36 is not correct, I think. All right, so Nicholas, are you still there? Can you please check my really, really bad binary mental? Okay, where's my calculator? Where's my calculator in binary? If I do 0, 0, 1, 0, 1, that is 40, exactly. And if I do 1, if I do, that's 5, and if I do, that's 20. Okay, so that's 40. All right. So of course, okay, and 40. Okay. Okay, I think we're ready to start. Uh, all right. What does the bit shift operator look like? Well, imagine we have the very simple number, the number 1, okay? The number 1 in binary is actually quite straightforward, is the digit 1 followed or preceded by all zeros, right? And the idea is that there's a very nifty operation that we can do, which is basically what's called shifting values. Or the idea is that when we do bitwise shifting, what we can say is we can ask for all the values of a particular block in bitwise. Let me say this. We're going to start over again. I didn't like this. Start over again, start over again. So what does the bitwise operator over again? Sorry about that. So what does the bit shift operator look like? Well, imagine that we start with a very simple value, the value of 1, which in binary is the bit 1 preceded by a bunch of zeros, right? And the idea is that there's this nifty operation called bitwise shift, which basically means taking all the zeros and ones of a binary representation of a number and then moving them to the left or to the right a bunch of positions. The bit shift operator is done with the two angular brackets. So for example, like I've written there, and if it's the angular brackets are pointing to the left, it means move all the zeros and ones however many positions to the left. What that means is that if I take the decimal value of 1, which this is its binary representation, and I shift all the bits to the left 7 positions, what will happen is that this number 1 is going to move 1, 2, 3, 4, 5, 6, and 7 positions, and it's going to end up at the very beginning of the 8 bits of a byte, right? Which will in turn result in this number converting to the value of 1, from the value of 1 to the value of 128, all right? We can do that with individual numbers, or we can do that with, or for example, we can do the opposite operation in the opposite direction. So what we can do is we can say, well, you know what? Take the value of 128 and do bitwise shifting 4 positions to the right hand side. What will happen is that this number 1 will move 1, 2, 3, and 4 locations, ending up on the 4th position, which happens to be the value of 8. Then again, but this works for one single number, but it works for basically all the zeros and all the ones. So if you take blocks of numbers, so for example, 1, 0, and 1, zeros are always meaningless in a way. So there's always like infinite zeros in front of you, right? So these are the numbers that actually make any difference. So if I bit shift all of those values 3 positions to the left, what we will end up is with this block of 0, 1, 0 moving 1, 2, and 3 positions. So it will end up somewhere like this, with this number being the decimal value of 40. And if I were now to unshift those values and move them to the right by 1 unit, what we will get is the value of the decimal value of 20, because all those zeros and ones have been displaced 1 block to the right hand side. Okay, what does that look like? Let's see how that looks like in the console application. So that will be bit shift is now whatever. Can I do bit shift like that? And 4, can I do that? No. Bit shift equals, oh, that's a thing? I had no idea. 128 bit shift 4. I think I just learned something new. I didn't know you could do the shorthand operators for bit shifting as well. Huh, nice. Beautiful. Okay, so that's 1 there, and then we can do bit shift equals 5 and then 3 positions. Is that what we did? And then we get here the value of 5 and then 3 positions. And then we do bit shift equals, then that's going to be 1 position. And then that's probably going to be, what did we have here? It was value of 40. Okay, so the value of 40 squared to one side, which should be a value of 20. And it does look like this. So we can bit shift the value of 1 7 positions to the left. We can then do, actually we can do shorthand operator. We can say whatever this was, can you please shift it 4 units to the right? And then we can take the value of 5, left shift it 3 positions, and then whatever that was, do right shifting one position, and then that will give us the same values that we saw in the example before: 128, 8, 40, and 20. Okay. Now, just as a wrap up, bit shifting can be a little abstract because it requires us thinking in binary, which may or may not be your thing. Just keep in mind that the advantage of this is that certain operations, not very common ones, but you will eventually run into these certain operations such as masks or such as, for example, certain arithmetic operations can be done at a much better level and much faster with bitwise operations like this. And hopefully in the next video, I will make a couple of samples of practical applications of how can we use to our advantage bitwise operation. Okay? So great. See you on the next video for a hands-on on bitwise operators. And in the meantime, if you found this useful, maybe you want to like this video, subscribe to the channel, say hi in the comments, all those things. All right? Thank you and see you. Let's do a hands-on in the next video. Bye-bye. All right, that was painful for some reason. Okay, I need to go. I have meetings this afternoon. I have a lot of stuff. So I'm not gonna be able to record the. I'm not gonna be able to record the example that I promised today, but we can do that at some point in the future. All right. Beautiful. Thank you very much, everyone. I have to go. I will see you around next week, hopefully. We are finally, I can't believe we are finally done with the advanced intro in Grasshopper. Can we give ourselves a round of applause? Wow, we're done. It's been almost a year. It's kind of crazy. And I'm going to finish Bitwise Operators next week. But what you can expect is that starting next week or maybe the following one, maybe for next week, we do an algorithmic modeling challenge just to have a little bit of fun with some geometry and architecture or whatever. And thank you, Nicholas. And I think we had on the works, we decided that this year we were going to do the brain plugin, a Git course. We need to do the brain plugin because I need to have that ready soon. The brain plugin, a Git course, and some Rhino Insight. So we're going to take a look at that very soon. Okay, so that's what you can expect coming up in the next few live streams. All right, thank you very much, everyone. Have a good weekend, and I'll see you next week. Bye-bye.